The project for this chapter is, again, about using technology for graphing. And so we're looking in this chapter about finding solutions to quadratics and other higher degree polynomials. And so we're going to use graphing technology to help us solve some of these problems too. So this is what we're looking at. This is what your project is going to look like too. Where you're going to be given a polynomial of some sort or some function to graph, and we're going to really work on making sure that we can use the graphing technology to not only see the entire image, or as much of the image as we need to, of the graph, but also to find some information from that graph. So I'm going to pull up my graphing calculator again. Here we go. And I'm going to walk you through using the graphing calculator. If you're already familiar with how to use the graphing calculator and set the window and find solutions, then you can probably skip ahead a little bit on this. But what I'm going to ask you to do is to input this equation into your graphing calculator. So up here in the top left, we have a y equals button. We've used this before. So we're going to input this equation, x to the third power. This arrow means to the third, or to the power of 3, minus 2x squared minus 11x plus 12. So there we go. Make sure you use this x up here by the alpha and the mode key and the second key. And if I graph that, I wish I can see part of that graph, but it definitely goes off the screen. And this is where I need you to be able to set the window. This is a third degree polynomial, which means that based on the fundamental theorem of algebra, we should have 3 zeros or 3 solutions. I see that it crosses the x-axis once, twice, 3 times. I feel like the count in Sesame Street. There's 3 roots there, 1, 2, 3. The only problem is we can't see the max and the min points. So my x value should be okay. I can see the 3 x values I really need to see. I just need to set my y values. So right up here next to window, or y equals, it says window. This is where we're going to set the window. So my x min and x max are probably okay because I can see the roots in that cubic. The scale, I'm really not concerned about. You'll notice here the scale isn't listed. I like to set the scale to something where I can see it, and I'll show you a different version of that in here in a minute. The y min and y max were not big enough. So let's maybe go to negative 20 and 20. Let's give that a shot. So if I graph that, so you'll notice that, I'm almost there on top. I'm going to have to get just a little bit bigger. My scale on the x-axis, I can see all those ticks. My scale on the y-axis, they're getting pretty close together, so it's harder to see those. Again, I'm not really concerned about the scale for this project, but I'm going to change my y scale. My y max wasn't quite big enough, so I'm going to go to 25, and I'm going to set my scale to 2. Let's see how that goes. That's a little better for the scale. There we go. I can see the entire graph. So what I need to have for this project is I need to see that your window fits this graph. Now, one thing I am going to be particular about is that it doesn't have to be a perfect fit. If you did 30, that would be fine. However, you can't just set it to like negative 500 to 500 and say, hey, look, it's on there. That's really not a good scale. That scale of negative 500 to 500 does not give me or really show what I need to see. It does show the graph, sure, but I need to see a little bit closer than that. And so if you did negative 30 and 30, that would be fine. I'm going to do negative 20 and 25. It doesn't have to be perfect, but it has to be closer. That you can't just set them all to negative 500 to 500 and call it good. All right, so I've got my window then. My x min was negative 10. My x maximum was 10. My y minimum was negative 20. My y maximum was 25. So setting the window, that'll be part of the assignment or the project, and then finding the zeros. So this is where not the zoom key, but the one right next to it says trace. And above that, it should say calc or calculate. So I'm going to use, since it's yellow, I'm going to use the yellow second key. Yours might not be yellow, but since it's up there, and I'm going to calculate. You should see one that says 0. It may not be the second one, but you should see one that says 0 or roots. And so I'm going to find the 0 or the roots. And then it should say something like this. We've got this little flashing beacon here, this trace mark, and it says left bound question mark. So I know there's a route over here because it crosses the x-axis over here. It has a 0 over there, I guess I should say. So I'm going to go left of that. Doesn't matter how far left. Could be right here. Could be right here. But I'm going to go left of that route. I'm going to push enter. You should see a little arrow here to say that, yep, I'm on the left side of it. And then it says right bound. So I'm going to go somewhere to the right of it. And then it says guess. You don't have to do anything with this, but I'm going to get somewhat closer. That's about right. I'm going to push enter again. And it found the 0. The 0 is at y is 0, x is -3. And so one of my solutions is -3, 0. Let's find the other one. So again, I'm going to do second calculate. I'm going to find a 0. And once you get the hang of this, it goes a little bit faster. I know there's a 0 over here, so I'm going to use the arrows to go somewhere left of it. That's left of it. Then I'm going to go a little bit right of it. And I'm going to get a guess right about there. Push enter. 1, 0 is another solution to this cubic. There we go. And the last one. So again, I'm going to calculate a 0. I need to go left of this last 0. So I'm going to go somewhere left of it. That's close enough. I'm going to go a little bit right of it. It's close enough. I'm going to get a guess. Again, close enough. 4, 0. Now, it may be that they're decimals. They're not always going to be whole numbers, but they might be decimals as well. So that'd be my solutions. So I've finished that part of the project. I've got another one. I'm not going to do this entire thing, but I'm going to show the window part of it again, and I'll do maybe one of these solutions. The next one here is a quartic, fourth degree polynomial, which based on our fundamental theorem of algebra, we should have 4 roots for this one. You'll notice it doesn't have a cubic portion. It doesn't go x to the 4th, x to the 3rd. For graphing purposes, we don't need to put 0 x cubed in there. If you're dividing, to use either the synthetic or the long division algorithms, you do. For graphing, it's fine to just leave it as it is. And we'll graph it. Let's see if it fits. Ooh, definitely goes off the screen. But I do see 1, 2, 3, 4 roots here. 1, 2, 3, 4, which means that I have all my roots that I can see. I have all the zeros. I shouldn't need to change my x min and x max for this one, but definitely need to change my y minimum. Y maximum, if you're not familiar with the quartic, a 4th degree polynomial is a W shape. And so I think my max is probably okay for this one. I'm going to leave the maximum of 25. Let's go with -30. Let's see if that fits. Nope, definitely not. Let's jump up. Let's maybe go -60. And just because it bothers me, I'm going to go by 5s now because my scale is going to get kind of tight. Oh, I think I got it. Yep, it looks like the bottom of those minimum points down here do show up. And so -60 worked. So that's my scale then. My window, excuse me, -10 to 10, -60 to 25. So I'm going to put that in. -10, 10, -60 to 25. I'll find one of the solutions because once you get that idea, you don't really need to see it over and over and over again. So I'm going to do one of these 4 solutions. So I'm going to do second calculate. I'm going to find the 0, enter. I'll just find this one. I'll find this one right here because it's the closest one. So I'm going to go left of the root that I'm looking for. And then I'm going to go right of the root I'm looking for. And you should see these arrows pointing towards that root. I'm going to take a guesstimate. Root was at 1, 0. So this one had a root, at 1, 0. Okay, so that's the idea. That's how the project is going to work. This is what the project will look like. This is what the project will look like right here. You're going to have a couple different functions to graph. You're going to window. You're going to find solutions, and and that's how it's going to work. So good luck on that. Make sure you get it to D2L.